All right, so this week's lessons are going to emphasize radical functions. So we're looking at things like square roots and cube roots, but still looking at the same characteristics. So the main characteristics of the graph, graphing with transformations, and solving. So for the table of points, for the parent functions here, we still want to use the x's and the y's. We would like to check negatives, positives, and zeros, and the easiest numbers possible that surround them. Those numbers just change a little. For example, for a square root, I can't calculate the square root of a negative number without using imaginary numbers. So I don't want to pick any negatives because they don't exist on my graph. I do want to see what happens with 0. And then positives that are near 0. But then when I get to 2, that's not a nice number to plug in. What is the square root of 2? There are nicer, easier numbers for me, and that's what I'm choosing here. So there's a rationale why we're checking these numbers and why you don't see negatives show up there. And so I'm going to plot these 0, 0, 1, 1, 4, 2, and then 9, 3. So our square root curve looks like this. It has this very distinctive endpoint because we couldn't plug in negative values. There aren't any transformations for our parent function. And then our HK is at 0, 0. And our domains for our square root function is not all real numbers, okay? The domain here, notice that the x's, we couldn't plug in negatives. We could only start at 0. So x's were greater than or equal to 0, or if you like interval notation, that's from 0 to infinity. And you see the same with our results. We got all positive values for results, started at 0 and went up. For our cube root function, again, same idea. We want that table of values. We want things negative, positive, and 0. Now we can cube root negative numbers, so I do want negatives. So I want 0, some negatives, and some positives. And I want to choose numbers that are closest to 0 that are specifically easy for me to cube root. So 1 is easy to cube root. 8 is the next number that's easy to cube root. And those negative values as well. So the cube root of 0 is 0. The cube root of 1 is 1. And the cube root of negative 1 is negative 1. The cube root of 8 is 2. And the cube root of negative 8 is negative 2. So negative 8, negative 2, negative 1, 0, 0, 1, 1, and 8, 2. So this is our cube root graph. It's growing, but real slowly. That's why it almost looks flat. Again, this is our parent function, so we don't have transformations here. So we see that same HK value at 0, 0 because we haven't done any transformations. And the domain here is all reals because we can cube root negative and positive numbers and 0, and we get all kinds of answers. So all reals as well for our range. Now we want to look at solving and the examples of graphing these with the transformations. So we're going to look at graphing first. One thing again, when there is this b value inside of our function, we want to rewrite it. So I want to rewrite negative 1/2 x plus 2, where negative 1/2 is the b value separated from the x plus 2. This turns out to be x minus 4. If you don't know how I got that, let's compare it to something you guys have done before. Let's say it was 3x minus 6. When you guys factor out the 3, you're generally very good at knowing that that's x minus 2. But think about what you really did. Because you factored out a 3, you took the first term, 3x, you divided it by 3, and you were left with x. You took the second term, negative 6, you divided it by 3, and you were left with negative 2. So that's what I'm doing here. I took the first term, negative 1/2 x, I divided it by negative 1/2, and I was just left with x. I took the second term, which is plus 2, I divided it by negative 1/2. So watch what happens here. I get negative 4 over 1 or negative 4. So if you're unsure every time, you want to make sure that you can figure that out. So this function that we're going to graph, we're going to think of it as a square root with a negative 1/2 as a b value and then x minus 4 in those parentheses, and a minus 3 outside the radical. So now I can see that a is 1. A has not been transformed at all. B is negative 1/2. H is 4. And k is negative 3. I'm going to write these down and write what they mean as far as transformations go. So for transformations, a is 1 is not a transformation. B equal to negative 1/2 is 2 transformations. Because of the negative, this is a reflection, and because it's a B value, it's horizontally reflecting. That means like turning the page of a book left and right. So that flips over the y-axis. The 1/2, remember how B works, we use the reciprocal. So really a 1/2 as a B value means I'm going to be multiplying things by 2. So this is going to be a horizontal stretch. My H value is 4, which is going to shift my graph right 4. And my K value is negative 3, which is going to shift my graph down 3. So then remember, this is a square root graph, and you want to have the parent function memorized, or you want to be able to quickly figure it out. And then you want to make a new table of points that will give you this new graph with these transformations in them. And remember, we focused on horizontal and vertical transformations. So the B and the H are horizontal. We have a reflection and a stretch, and then a shift to the right 4. For our vertical transformations, there's just one. We have a shift down 3. So those y coordinates are all going to get 3 subtracted from them. And then we're going to go through and perform these operations on the different x and y values. So I'm going to use each x, multiply it by negative 2, and add 4 to get a new x value. 2, when I plug in 4, I get negative 8 plus 4. And when I plug in 9, I get negative 18 plus 4, it's negative 14. For my vertical values, when I plug in 0, I get negative 3. When I plug in 1, I get negative 2. When I plug in 2, I get negative 1. When I plug in 3, I get 0. So I'm going to plot these points. So 4, negative 3, 2, negative 2, negative 4, negative 1, and negative 14, 0 will be somewhere down here. Now, sometimes when you guys draw the square root graph, it's a little hard to know which direction to go because it has that distinct endpoint. But remember, in the parent function, that endpoint was at 0, 0. 0, 0 has been transformed into 4, negative 3. This 4, negative 3 point should be my end point, so it continues towards these other points. So there's my graph. I have the table and I've listed the transformations, and now let's list our new h and k values, that 4, negative 3. And then looking at the graph, you can see the domain and the range values. So the domain, notice that now your starting point for x is here at 4 and it's only plotted to the left of 4. So I have a domain where x's are less than or equal to 4. Or in other words, from negative infinity up to and including 4 for x values. And then when we look at that graph, the y value that endpoint is at negative 3, and the graph goes above that. So the y values are greater than or equal to negative 3, or including negative 3 up to infinity. Now we're going to go through our cube root example. In our cube root example, we don't need to rewrite the equation because you see there's not a b value here that's different than 1. So we can see right away our a is 2, our b is just 1, it hasn't been transformed. Our h is negative 2, and our k is 6. So as far as transformations go, with an a value of 2, that means we're timesing things by 2. That's a vertical stretch. Our b is 1, so no transformation. For h to be negative 2, that means we're going to shift left 2. And for k to be 6, we're going to shift up 6. So again, when you make your table of points, you need to start with your parent function, and your parent function is something that you have a way to remember quickly or you have memorized. Then you're transforming that to make your new point values. So what did we do horizontally? Horizontally here is just our h. We shifted it to the left 2. So all the x coordinates of the points, we will subtract 2 from them to move them all to the left 2. And then vertically, we have a and we have k. So vertical stretch means we're doubling the distance. So we're going to double that y value. And then to shift it up 6, we would add 6 to those points. And so now we're going to go through and one by one adjust our x and y values. So I'm going to plug each x value in here and kind of subtract 2 to move it to the left 2. So negative 8 minus 2 is negative 10. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 8 minus 2 is 6. Now if I go through and do the same thing for the y values, when I plug in negative 2 times 2, I get negative 4 plus 6, it's 2. When I plug in negative 1, I get negative 2 plus 6, which is 4. When I plug in 0, I get 6. When I plug in 1, I get 2 plus 6, which is 8. And when I plug in 2, I get 4 plus 6, which is 10. So I'm going to plot these points, negative 10, 2, negative 3, 4, negative 2, 6, negative 1, 8, and then 6, 10. Then I'm going to draw in that cube root function curve. There we go. Okay. Now, my h and k values, I saw 0, 0 transform to negative 2, 6. That matches my h and my k. The domain of each cubic is all real numbers, and so is the range, even though it grows very slowly. So that should help with graphing, and now we want to look at how to find the intercepts. So we're going to look at those here. So again, I'm going to start with the y-intercept because I think the calculation's a little simpler because the equation's already written exactly how I want it to do that calculation. So I'd have negative 1/2 times 0 plus 2, and then outside the radical minus 3. So negative 1/2 times 0 is 0 plus 2 is 2. And again, we don't want decimal approximations for our radicals in this unit. So you guys are just going to leave it just like this. So this is my point. And if you're not sure what that is, remember rad 2 is like 1.1 or 1.2. Can you do that minus 3 and get the y coordinate you expect? For the x-intercept, we're going to plug 0 in for y. And now we have to solve for x. So again, x is trapped inside of something. Notice that the x's of the problem are underneath this radical. So the first goal is get the radical alone, and then we'll figure out how to deal with the radical. So we're going to add 3 to both sides. And then how do we get rid of a radical? Well, when we had a squared, we use a radical. Now when we have a radical, we want to squared, and squaring that radical will cancel out that operation and just leave us with the expression inside the radical. Now we want to finish solving for x like we normally would. So I'm going to subtract 2. And then I'm going to multiply by negative 2 to cancel out that 1/2, so that those will be like a 1. And I get negative 14. So my x-intercept is negative 14, 0. Now, one thing to be aware of, a big note for yourself about the radicals. The radicals cannot calculate radical of a negative number, except for using imaginaries, which we're not using here. So if I had plugged into my y-intercept, if I had gotten a negative underneath the radical, I would have stopped calculating and wrote no solution. That same idea applies for the x-intercepts. You really, really, really need to check your answer here. And I'm not just saying like, oh, all good math students check their answer, but you might have gotten something that makes a negative underneath the radical. So you just want to make sure that when you plug negative 14 back in here, you don't get negatives underneath the radical. So you need to be on the lookout for negatives underneath the square root, and that those are equivalent to no solution. And the way you're going to look out for that is you're going to make sure that you don't end up with a negative when you're calculating the y coordinate. And you're going to have to check that when you plug your x value back in here, like negative 14, that I don't end up with a negative underneath this radical here. I'm not going to make that same note for the cube root, because remember, you can cube root negative values. So here it's not nearly as important to check. If you've done everything right, your answer is going to be right. So for my y-intercept, I'm going to plug in 0 for x. Inside this cube root, I get a 2. And again, we don't want a decimal approximation here. So we're just going to leave 2 times the cube root of 2 plus 6. That's my y-intercept. For my x-intercept, I'm going to plug 0 in for y. And again, the x's are contained inside this radical. My first goal should be to get that radical piece alone. And I'm going to do that by subtracting 6. And then dividing by this factor of 2 that's multiplying the radical to get it to cancel out. So I'm going to have negative 3 equals the cube root of x plus 2. Now, how do I get rid of a cube root? When I was cubing, I used the cube root to cancel it. Now that I have a cube root, I'm going to cube. That would cancel the radical, leaving just the expression inside of it, but I must also do that here. Negative 3 times negative 3 times negative 3 is negative 27. And then I finish solving for x and get negative 29. So my x-intercept here is negative 29, 0. And again, I don't need to check this one. You can, but you don't need to because it doesn't have the same properties as a square root function.